Now let's take a look at the handout that details the steps that we take. This repeats everything that comes from the slides. And in our Excel spreadsheet, we wrote or typed out the labels for all of the categories here in column A. And then in column B, this is a column that is not shown here on the table in the slide, but it's necessary for Excel. So let me go back to that. Or at least it's necessary if you want to use these proportions to calculate your expected frequencies without error. And so we put the proportions here, the proportions that we expect, the proportions from prior distributions. And then in this column I have labeled that O for the observed, and these are the counts that we got from our sample, so I placed those in column C. And now the next thing I do in instruction 2 is I calculate the expected frequencies by multiplying the proportion times the sample size. So the formula I've typed in here is equal the sample size, whatever it was. It turned out to be 100. And then I multiply that times the expected proportion. Don't put 0.13 in here. Put B2 if that's the cell that you use. Put the cell, identify the cell that that first proportion is in, and that way you can grab the little green square here and pull down and autocomplete. And so after we pull down and autocomplete, we have our expected frequencies here: 13, 20, 14, 16, 24, 13. And then the next thing we need to do is, in this cell, we want to subtract the expected from the observed. So we type equals. In this cell we type equal, and then we put the cell with the first observed frequency, as it says here, which is cell C2, and then we subtract the first expected frequency, which is cell D2. It's kind of unfortunate that I have column E here and the expected frequency is E in column D, but that's the way that's the way I set it up when I created this document, and I didn't really want to go to the trouble to rework it. If you were in class, you alerted me to the fact that there was a typo. I think there was a typo right here. I did have E2, and that's probably what threw me off. Anyway, for this table, the formula that I need is equals C2 minus D2, because it's this cell minus this cell. Then you grab the little green square and pull down so that you autocomplete, and you have all of those, all of the correct differences in that column. Then, in instruction 4, oh, and by the way, I noticed that it says after typing enter. Once you put a formula into Excel like this, you have to type enter so that you get out of the cell, and then you go back and click that cell, and that's when you can grab the green square. For some reason it doesn't work unless you hit enter to exit and then go back to it. So so in the next cell, which is in column F, you want to square these differences. These are differences, see. O minus E in each case. You want to square each of those. So in that first cell, which is cell F2, you type the formula equals cell E2 squared. It's again, it's a little confusing that these are the expecteds, but it says E here. We're talking about the cell here, cell E2. So you type equal E2 and the caret, which is Shift 6, and on your keyboard. And then you hit enter, and then you grab the little green square and autocomplete down. And then in the observed minus expected squared divided by E column, which is column G here, I use the formula equal F2, which is the first of those O minus E squareds, divided by D2, which is the expected frequency that corresponds to it. And then again, once I do that, I hit the little green square and go back and autocomplete from here down to cell G7. You can type those in individually, but it just makes much more sense to use autocomplete. And now the last thing that you do here is in a conveniently located cell, and I just chose the one at the very bottom of these calculations in column G, you type equal sum left parenthesis, and then you either select G2 to G7 or you type in G2 colon G7 and close your parentheses. I believe on the document I handed out, I put a forward slash here. I think that this this was not labeled correctly here, and this was not labeled correctly here either. But as you can see, I've corrected that, and I've uploaded this corrected document into the files section of our class website. So now this is the way your spreadsheet should look, and you see at the bottom the test statistic is 6.68200, so that makes it very clear that we should round to 6.682. Now, to find the critical value, we have 6 categories, so our degrees of freedom are 5, and the area in the right tail is 0.05. And so just as I said in the slide, I have that indicated here in the graphic, this portion of the chi-square distribution, and it shows that the critical value is 11.071, which is just what we said in the presentation, in the PowerPoint presentation. And so because that test statistic is below the fail to reject region, we fail to reject the null hypothesis. It's not in the critical region, so we fail to reject. And so this tells us that the original claim does not contain the condition of equality, and since we fail to reject the null hypothesis, we conclude there is not sufficient evidence to reject the claim that the distribution is as Mars claims it is. So that's all for the hypothesis test of claimed distribution.